In this video, we'll learn to solve trigonometric equations by factoring. In example 1, we have sine of theta times tangent of theta minus sine of theta. Hopefully you can see the factoring method you'll use here. We have a GCF, greatest common factor, in each of our two terms of sine of theta. So we'll factor out sine of theta, leaving us with tangent of theta minus 1 equals 0. Our zero product property tells us that our solutions are sine of theta equals 0 and tangent minus 1, rather tangent of theta minus 1 equals 0. On the unit circle, we can see that sine of theta is equal to 0 at an angle of 0 degrees or at 180 degrees. The second solution, we have to add 1 to each side to solve it, and we get tangent of theta equals positive 1. Tangent equals positive 1 when sine and cosine both have the same value and the same sign. They're either both positive or they're both negative, and they're equal. That only occurs at 45 degrees and 225. Again, if you want to express these in radians, or if you were asked to, 0 and pi. 45 degrees is pi over 4, and 225 degrees is 5 pi over 4. There's our solutions. Example 2, we have cosine squared x minus 2 times cosine x minus 3. Now this one is a little bit more involved. This is an example of ax squared plus bx plus c equals 0, right? That's a quadratic. And the factoring method that I use is that big X. Now, before you start with one of these, because they're a little bit intimidating to look at, and I think I mentioned this in class, I first want you to just say, we're going to let cosine of x equal some variable. I don't recommend using x. You'll get confused because you have an x here. So you can use, we'll use a. You can use any variable you want. If you wanted to use theta, you could use it. We'll use a. So we're going to rewrite the equation as a squared minus 2a minus 3. And that should be much simpler for you. So you can use the big X. You might not need the big X for this one because it's such a simple problem, but here it is, just to review how it works. We multiply a times c, we get negative 3, and then we take b, negative 2 on the bottom, and we say what factors of negative 3 add to give negative 2. The factors are negative 3 and positive 1. Put a fraction bar over the top and bring down the variable from the first term with its exponent cut in half, which in the case of a quadratic means no exponent or exponent of 1. So our factors are a minus 3 times a plus 1, and that equals 0. Using the zero product property, we have a equals 3 or a equals negative 1. Substituting back the trig ratio that we took out earlier, we have cosine of x equals 3 and cosine of x equals negative 1. And now we're back to the unit circle. So if we look at the unit circle, where is cosine equal to 3? Well, it isn't. It's not equal to 3 anywhere on the unit circle. It's outside of the range of values that exist for the interval that we're solving for. So no solutions, or the angle doesn't exist. You may see DNE does not exist. But where is cosine equal to negative 1? Well, cosine is our x value, and it's equal to negative 1 at 180 degrees, or in radians, pi. Okay, last example. This time we have another equation in the form ax squared plus bx plus c equals 0. But this time we have a leading coefficient of 2. These are typically a little bit more challenging. We're going to do the same thing again. This time my variable is theta, so if I wanted to use x, I could, but I'll stick with our previous example and use a. So we're going to say let sine of theta equal a, and we'll rewrite the equation. 2a squared plus 3a plus 1, setting up our big X. 2 times 1, that is a times c, gives me positive 2, and b is positive 3. Factors of 2 that add to give 3 are 2, positive 2, and positive 1. I like to put the signs in there, just aids in readability later. And we'll bring down our variable. Now, when the leading coefficient's not 1, we include that. 2a. And here's the critical step. When the leading coefficient is not 1, we have to attempt to reduce at this point. Sometimes it won't reduce, usually it will. Usually just one side. In this case, 2's reduce, and I'm left with a factor in the denominator of 1. And it's important that you write the 1 in this case. Remember, this is an organizer. This is not really mathematics. Now that I have the fractions reduced, I have my two factors, a plus 1 times 2a plus 1. And if we FOIL that back out, here we'll do this and I'll erase it. A times 2a is 2a squared. A times 1 is positive a. 1 times 2a is positive 2a. And 1 times 1 is 1. Combining like terms, 2a squared plus 3a plus 1. And that is what we started with. Equals 0 here. So factorization is correct. I can now solve these. A equals -1. 2a equals -1. Dividing by 2. I get a equals -1/2. And now I'm going to substitute back in sine of theta for a. So sine of theta equals -1. Sine of theta equals -1/2. And we'll look at our unit circle. We see that sine is equal to -1 at 270 degrees, or 3 pi over 2. And sine is equal to -1/2. I should have two locations here, at 7 pi over 6 and 11 pi over 6. In degrees, that's 210 degrees and 330 degrees. So hopefully you're well on your way to factoring trigonometric equations by factoring.